Yeah, so the title's actually kind of a pun or something. So, yeah, so hi, I'm Paul Syverson from the Naval Research Lab. If you don't know me, thing I'm probably most known for is I invented onion routing with a couple of my NRL colleagues forever ago back in the 90s, and then a few years later with a couple of non-NRL colleagues created a version of that we called Tor. And this is the main thing I've been working on pretty much ever since. What I've been working on mostly for the last several years, advance, there we go, is the question of there's a lot of domain names that have associated onion addresses. If you don't know what an onion address is, I don't have enough time to explain it, so for our purposes, you can just think of it as pretty much like a PLC did because it's a cryptographically self-certifying address. And domain names are generally human meaningful, and onion addresses are these cryptographically things that are not. And turns out how to discover when things are associated and how to be sure they're bound together has all kinds of problems that has all kinds of problems and which I have spelled out in all of these papers that I'm not going to actually talk about, but that's there if you want to go look for them. And then also, fortunately, solutions to these. What are the goals of the work here is to sort of synthesize those things with at proto-identities, so handles and dids, with a couple of goals. One is to improve and generalize Bluesky verified accounts to be more than they are now, explicit about who the verifier is, and also to provide some context, to be decentralized, so it's not limited just to the Bluesky trusted verifiers. And also open so that anybody can have a verified identity. And in addition, we want to synthesize these together in a way that allows us to have self-certifying meaningful identities that are consistently transparent, that are blocking resistant. This is one of the things onion services provide in a way I won't explain. And robust to TLS certificate hijack. And also, everything we've done is sort of fully backwards compatible so that if you are running something that doesn't know anything about our stuff, as long as it uses the standard protocols, nothing's going to break. You won't get the advantages, but nothing's going to break. So this is joint work with the force of nature, who is Nick Jarakinas, who's right there. Yes. So suppose, as an example, I didn't know about smoke signal, and Nick says, oh, here's this cool thing, smoke signal, you should check it out. And let's assume that he and I have a trusted channel over signal, and we've validated that, and that I trust Nick about identifiers for domains, or maybe just for particular domains. We can come back to that. But what if smoke signal.events has a TLS hijack? So just what I mean by that, well, if you go to smokesignal.events, you get the usual lock icon, and if you click on that, you can see a certificate that says that an authority, in this case Let's Encrypt, says, oh, the key that's authenticating this connection is in fact associated with the name smoke signal. So that's great. Only problem is it's way too easy to obtain bogus TLS certificates. It's not completely trivial, and a lot of people have done a lot of work to make it harder, but I don't think this is a problem that's going away anytime soon. It's just a big bad problem. So the answer, what if it gets hijacked, is somebody can basically set up their own version of smoke signal and get me to think whatever about upcoming events, or maybe reveal some kind of sensitive information in the course of RSVPing. So in general, a bad situation. But what if instead of given me just the link to smokesignal.events, the URL includes the PLC did for smokesignal.events. And again, we have the trusted channel that I'm getting things from Nick from. Now, if I go and follow that URL, we have a Firefox extension that Nick created that ultimately I would like this to just be built into Firefox, but you need to crawl before you walk. This extension checks that the key there's a header that gets sent, and it makes sure that the key that signed the header is in fact associated with this did, and that further that the did that's in the did document matches the did that was in the URL. As opposed to if, for example, there was the did was not a good did, then you would fail the checks. So, great. So this is provides what I like to call dirt simple trust. The idea is all I need is the address, and I'm kind of done. That's enough. I can't be hijacked or anything as long as we have this. I discovered it in this way. Relatedly, it also offers what I would call authority independence. So the idea is no authority, no CA can say, oh, no, here's the new key for smoke signal, because they don't control the key that is associated with the did. I can't be tricked about that. So because I learned of this URL from Nick, and because it passed the checks when I tried to connect to it, I can trust that Nick told me that the handle and did are in fact bound together, and further that because I trust Nick, I can trust that they are bound together. But we're not quite done, because in order to do this, we had to have this, signal exchange. And Nick has been very tolerant of me, but I think if every time I wanted to have a secure connection with anything, I had to have a signal communication with him, maybe that would try even Nick's patience. So we therefore have it automated so that we have a record that you get a signed header that's signed by, say, njerakinas.me, as well as by smoke signal, that says that these are bound together. And further, and this is where I'm introducing contextual labels, it could have a label like, for example, this is a Nick project. This is a project that Nick did. So let's contrast this with the way Bluesky currently handles verified accounts. So Bluesky will directly verify somebody's account as belonging to someone, but they also have a handful of trusted verifiers. And that's fine, but it has some limitations. For one thing, you have to be important in order to get a verified account, or you have to be affiliated with one of these. There's about 20 currently trusted verifiers. Most of them are journalism organizations, and I mean, I think that's great, but the rest of us are just SOL if we don't have, one of these affiliations. So what we have is, it supports that kind of functionality, and I think should replace it. So you can just do the same thing. That's what I've got here on the left, your left, whatever. But it doesn't have to be centralized like that. You could also have, say, like the town of Springfield is going to tell you what the local entities are in Springfield. So you might have a local news source in Springfield, and this is a good way you can resist pink slime journalism, because you won't have somebody from far away masquerading as being from Springfield. Or it can also be even at the individual level. So this scales both up and down. So like if you're somebody, I just made this entity up, but as far as I know. But you have somebody named Vegan Piper, maybe you trust them about where there are vegan restaurants around, but maybe you don't trust them about that, but you do trust them about bagpipe supplies. So you can choose which you want to trust them on. So don't have a lot of time here, so that's it, and I'll be happy to take any questions.
Do we have any questions for Paul? We've got a couple of minutes.
Hooray!
Yes, all right. For the record, those of us at Bluesky also think that they should replace the verification system.
No,
so,
you know, you have to crawl before you, you know, real problem that was being solved in real time
Sure.
right away, and clearly the right thing to do. But I think this is a good migration.
Yeah, absolutely.
So, I think there was
Fantastic.
a question over here.
Oh,
Or did you change your mind?
yeah.
Hi, yeah, I was just wondering if you've investigated in your work putting the signature information or any kind of that relational information on the atmosphere itself. I get why it has to be in the HTTP signatures, but if there's any connection to like some sort of record that this person trusts this org or something like that.
Well, yeah, it is.
Yeah.
It's in there. I mean,
So there's you know, like you talked, so a lot of content made it onto the floor, unfortunately.
Yes.
But the idea is that the HTTP signature could reference, for example, could include an AT that is in the repository that has more involved contextual trust information, and the DID documents themselves represent a whole lot of information. You can have key controllers, identity controllers, also known as relationships, and the bidirectional relationship representing consensual referencing for DIDs, keys, verification methods, etc., and even shared keys across them can show that, hey, this identity, you know, is affiliated with John Hopkins, for example, which is affiliated with, you know, a parent entity and so forth, and the trust can be traversed using those methods. So that's the idea.
In my role as MC, I'm going to move us along, but do please talk to Paul and Nick.
As I say, for the benefits of people online, what was asked was, well, is this directly built into AT? And the short version is Nick said yes.
Excellent, fantastic. Excellent.